The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our next speaker is Lars Balck. He's a professional engineer, graduated University of Florida, spent 3 years in the Army at the wrong time and during the Vietnamese War in the airborne as Ranger. Worked for 2 years with RMK BRJ building bridges around Saigon and pads and bunkers around the DMZ. Since 1972, he's been with the CROM Corp, building pre-stressed shotcrete tanks, has built approximately 400 tanks or more than that. Worked with Ted CROM, who was one of the original people on the 506 committee, trying to improve the quality of shotcrete by developing Nosman certification. They had their own Nosman certification program long before the ACI. He's past president of the ASA, past chairman of the 506 committee, and has chaired the 506 subcommittee on the guide for approximately 10 years. We can't figure out exactly what it is. Lars?
I'm here to talk about the guide. First thing I want to do is, let's see if we can get this to work. Shotcrete is concrete. I'm going to repeat this a few times. I'm going to drill it in your head. There's not much difference between shotcrete and concrete. Shotcrete is concrete that's pneumatically placed. Or we've changed the definition now. It's placed at a high velocity on a properly prepared surface. What's the difference? I'm saying that they're the same. I guess there's a little bit of difference. Concrete, how many of you are paratroopers? Okay. Concrete is the shotcrete as the infantry is the airborne. They both do the same job. But they get there differently. Concrete is vibrated to achieve consolidation. And shotcrete is consolidated by impact. Shotcrete is used in a lot of different structures because it is so uniquely placed. It can be used for new construction, linings, tunnels, lining on the underside of tunnels or mines. It's used more and more in repair. Reinforcement, seismic reinforcement in California, ground support, soil nailing, refractory. Wherever you have a one-sided form, shotcrete is ideal, which makes it ideal for doing a lot of repair work. In conjunction with the use of fibers, particularly in mine linings, you save a lot of labor instead of putting up all that steel. By adding fibers, it's a good marriage between shotcrete and fibers. Be a little bit of history about shotcrete. Carl Ackley came up with the design of the cement gun. And then in the 30s, cement and gun companies started producing equipment to place shotcrete. In 51, ACI developed the term, it used to be called gunite, but ACI used the term for shotcrete and divided it into the two processes, one being wet mix, the other dry mix. Here's a little sample of how shotcrete was being placed years ago. Not very safe and poor application technique. Here's another early example of shotcrete. Again, would not pass as a OSHA poster boy. Now the guide, 1966, was the first guide. It was not called a guide then, it was called recommended practice. About the same time, Al Litvin with, I think it was the PCA at that time, which is now CTL, compiled a lot of information about shotcrete. And since then, there's been a great deal of development in the equipment, particularly on the wet mix side. And in '78, Ted CROM, as mentioned earlier, really got involved. His involvement was in '53, we were building, the CROM Corporation was building pre-stressed tanks using shotcrete for the wall construction. He realized then that to get good quality, you needed to focus on the application of the shotcrete, and to get good application, you had to get good nozzlemen. So he started pushing for the certification of nozzlemen and published that. Back then, everything was being done at the CROM Corporation with dry mix. Then in 1980s, wet mix expanded, and we converted over to wet mix. In '83, the guide to shotcrete was revised, and improvements in equipment continued to expand. And 2005 was our latest edition of the guide. Now, since then, 1999, about 2000, the American Shotcrete Association was formed to promote the use of shotcrete. And they've also done a good job of training and educating people about shotcrete. And so, partly because of that and because of the efforts of a lot of contractors, material suppliers, the volume of shotcrete has increased. The number of jobs, the type of work that shotcrete is being used at has expanded. Both organizations, American Shotcrete Association and ACI, have been focusing on improving the quality. Shotcrete has gotten has a poor image, and by focusing on quality, we're trying to improve that image. Now, the guide, what it isn't, I want to point out, it is not a how-to book for contractors. It is not a design guide. That's left with the structural engineer. And it's not to be used in specifications. Us contractors have seen where sections have been lifted out of the guide and placed in specifications. Specifications are mandatory language, and the guide is not mandatory. If references are going to be pulled out, it needs to be rewritten. Now, a number of years ago, we recognized that we have a lot of documents, the 506 committee. We've got the specification, the guide, evaluation, qualification, and a fiber reinforced document. We wanted to better integrate those. So we came up with reorganizing the guide, and we basically are reorganizing it around the specifications. So the first 3 chapters, the specification has 3 chapters, general, materials, and execution. So what we did is reorganize the guide such that the first 3 chapters in the guide serve as commentary, paragraph by paragraph with the specification. The other 4 chapters, well, there's 8 chapters because there's references. The other 4 chapters, equipment, crew, safety, and sustainability, that is guidance. And it's pretty much the same as what we had in the previous editions of the guide. We had a little section in the previous guide on history and application, so we've stuck this in as the introductory portion of the new guide. And then in chapter 1, again, it matches the chapters in the specification. We made a deletion in the old guide. Well, the old practice, there was a pay per a portion of work that you used. We've taken that out because we don't believe we won't be involved in any contractual relationships. Submittals, as Phil mentioned earlier, submittals are critical. Want to get in there information about the nozzleman. A new element that we've put in this is qualified contractor. The nozzleman is extremely important in placement of shotcrete, but the entire crew is also critical. And the contractor, because he controls the tools that the nozzleman has. All nozzlemen want to do a good job, but if they're not given the right tools, enough time, improper materials, you're not going to get a good job. So the contractor is really key. We're putting emphasis on qualifying your contractor, and that's part of the submittal process that Phil mentioned earlier. Along with that, pre-construction testing. Again, check out whether the contractor can perform the work that you want performed. Now, if it's something that's been done repeatedly in the past, you don't need the pre-construction testing. But if it's something new, overhead, large bars, closely spaced, congested steel, do some pre-construction testing. If you've got special mixes that there's no history on, do some pre-construction testing. If you're concerned about finishing, what the finish looks like, do some testing. In the new guide, we've expanded, as Phil mentioned, we're trying to clear up what the owner needs to be responsible for, what the contractor needs to be responsible for. Part of the QA, we're putting in a table that Jim Ragland is presented and worked on, and he is presenting a new concept where you look at your project and determine whether your shotcrete has 3 different degrees of difficulty: a regular project, or a difficult one, or extremely difficult. Difficult one would be overhead, congested steel. But a regular shotcrete wall that you've done many times, that would fall under difficulty 1. He's going to go into greater detail on that later. Panels. Phil mentioned about panels. There are several different types of panels because they have different purposes. Now, panels can get very heavy. With material panels, we want them thick enough such that we can get a proper L over D. We can't take the cores too close to the edges, otherwise we'll get, in shooting into a form, you'll get a little blowback and you'll get some voids. So you don't want to get your cores too close to the edge. Consequently, you can get very large panels. Right now, as Phil brought out, ASTM and 5062 are a bidding conflict. Now, there are other types of panels. The first panel for materials, you're looking for a sample to do a compression test, typically. You've also got qualification panels, and this could be a mock-up. This is the pre-construction testing we talked about earlier. You can build that whatever you want. make it to be the most difficult thing that's on your project. So it can vary in shape and size. The other type of panel is the nozzleman evaluation. That is only used to evaluate the nozzleman. And CP60 has a standard panel and a method and procedures for evaluating nozzleman, grading the cores taken from that panel. Materials, as you all know, in the last 10 years there's been an explosion of new materials. Fly ash, silica fume, slag. And what we've done is expanded the information about those materials in our document. We're trying to make this document somewhat inclusive. Air entrainment. Shotcrete is a bit unique than concrete. With concrete, it just drops into the form. With Shotcrete, the material coming out of the nozzle, when it leaves that nozzle, your air entrainment is lost. It's blown in the air. So you could have 6, maybe 10% air entrainment. But what you'll get on the wall is 3 to 4%. That's all you can expect. Don't specify 6% air. Our document says 6% in the pump prior to placement, but only expect 4% on the wall. Now some shotcreters will put in as much as 10% air to facilitate pumping, but they'll only get 4% on the wall. Evaporation retardants are being used, so we talk a little bit about them. And we want to give some caution. There's new materials. We give some cautions on the limitations of supplemental materials, which we're basically taking out of 318. Boiled water absorption has been a hot topic that we've discussed for a long time. And what we're doing is we're now saying take the Shotcrete mix, not the Shotcrete, but the mix, run boiled water absorption on that, and then when you place your Shotcrete, take your sample and compare your Shotcrete results with the Shotcrete mix results. Flexural strength, more and more fibers being used, so what we've done is we pulled the information from the fiber reinforced document and put it in the guide. Slump is another subject that's caused a lot of discussion. Typically, shotcreters, if you ask them what slump, they'll say 2 to 4 inches. But with all the admixtures that's being used, particularly if you're in a tunnel where you're adding a hydration retardant so that you can pump it a long ways, and then you add an accelerator at the end, the measure of slump is difficult to do. So what you need to do, go back again to pre-construction testing. The 2 to 4 inches is just a general rule of thumb without a lot of chemicals, without drugging up your mix. We put some emphasis once again to achieve proper strength. We need sufficient compaction consolidation, and to get the consolidation we need sufficient impact velocity. We discussed temperatures of cold weather, hot weather, and cold weather and hot weather, and we also expanded the methods for curing and protection. After you place it, what you need to do to protect the Shotcrete. Those are basic block and tackling, as with all concrete. Tolerance has been a big subject that we've discussed. And what we've done in this document, we've referred to ACI 117. 117 is an excellent document. However, it says it doesn't apply to Shotcrete. And the reason, I don't know for a fact, but the reason I believe is that Shotcrete has so many more applications than concrete, they didn't feel like they could adequately cover it. But the basics that, basic parameters that is in ACI 117 still apply to Shotcrete. And we go in and give some more detail and advice and guidance on tolerances. You as the designer need to decide what is important, what is the proper tolerance. Inside of a mine, you could have 2 or 3 inches of cover. In other locations, you want very tight tolerances. When we build a tank, the final finish, to make it look good, is extremely tight tolerances on the finish. So you as a designer need to determine for your project what is important. Because more and more structures are in need of repair and Shotcrete's being used more and more as a method of repair, we've gotten into, added this chapter on repair. Acceptance, another hot topic, as we discussed earlier, particularly encasement of reinforcement. So we've gone into some detail on that. Equipment has changed. We've expanded to include the new equipment that is being used in Shotcrete, robotics. The crew, we've kept a chapter on the crew because we feel it's extremely important. The nozzleman is critical for a proper Shotcrete application, but the crew that supports him, that works with him, that team is extremely important. Safety. I don't know of any other ACI document that has anything on safety. We have included safety in our document as a separate chapter. It's a new chapter because Shotcrete has a lot of specific hazards. Now, we're not trying to put together an all-encompassing manual. What we're trying to do is point out what are the hazards. With Shotcrete, you've got high-pressure hoses. You've got equipment that's rotating. You've got potentially confined spaces. We've also going to put in as a checklist, as an appendix, a checklist for the user. Another chapter, sustainability is becoming big, and Shotcrete is just ideal for sustainability. We use half the formwork. We only need a one-sided form. The other part that Shotcrete plays well with sustainability is that it can extend the life of structures. You don't need to tear them down. With Shotcrete, you can repair them. Chapter 8 is our reference chapter. These are the men that have guided us, promoted us, and helped with the Shotcrete industry. There'll be another edition, and we're probably going to get more and more into robotics as the years go on and do a better job of integrating with the present documents. I believe Shotcrete's better than concrete. To place Shotcrete, you have to have enough cement so that you can pump it through a small diameter line. So that ensures that you've got enough cement. You can put junk in a bucket and pour it, but you can't put junk and pump it through a line. You have to have a low water cement ratio. It will not stay on the wall if it's got too much water in the mix. You can pour an 8-inch slump on the ground, but to stay on the wall, you have to have a low water cement ratio. So those two elements, sufficient cement and low water cement ratio, ensures we get good quality. I build tanks, and so in closing, tanks and gunite.